Dear students, let's learn more about the chapter units and measurement. So, before proceeding further, I would like to attempt a objective question from the last topic. The last topic that we had discussed was the rounding off rules. So, based on that we have a question which is objective, where there are 4 options are there. So, let us see how to solve them. A substance of mass 49.53 gram. So, mass is given 49.53 gram, occupies 1.5 centimeter cube of volume. So, volume is given, it is 1.5 centimeter cube. The density of the substance in gram per centimeter cube with correct number of significant figures is. How do we find the density? Density is always the ratio of mass to the volume. The value of the mass is 49.53 divided by 1.5. Now, this is an objective question where we are not supposed to use the calculator. Then how to get this particular answer? So, let us use the technique or the rules which are used in rounding off a digit. So, whenever we divide a quantity, in the final answer, the number of significant digit should be equal to the least number of significant digit in the given data. In the given data, here there are 1, 2, 3, 4 significant digits are here. In the given data here, there are only 2 significant digits. That means, in the final answer, there has to be only 2 significant digits. Now, refer the options. In option A, there are 2 significant digits. In option B, there are 4. In option C, there are 3 significant digits. And in option D, there are 4 significant digits. So, therefore, now you can very easily guess which is the correct answer. So, answer is option A. So, that is 33. So, therefore, you can see here we do not have to sit and divide. Based on the options given, we can predict the answer. I hope you are clear with the rounding off rule, and that is an object. So, these kind of questions are possible for any of the competitive exams. So, let us try one more question. Each side of a cube is measured to be 7.203 meter. So, each side of the cube. So, let that side be A, 7.203 meter. What is the volume of the cube to appropriate significant figures? So, we wanted volume. How do you find the volume of a cube? The volume of a cube is A cube. So, that is 7.203 cube of it. So, you can make use of the calculator and then find the answer, and then you can forward that in the group, so that I will let you know what is the exact answer. So, this is an exercise. You can post the answer in to my number also. You do not have to post even in the group. So, you can do that. So, let me know what is the exact answer according to the rule. So, let us learn more about this unit and measurement. Measurement of large distances. See, as we know, all the celestial bodies, the sun, moon, the various other stars, other planets, other comets, correct? They are at very large distance, correct? When they are very large distances, how do we measure the distances? That is the first point. And do we use the same unit as that of the distance or the length, which is meter? So, the answer to the first question, how do we measure? So, there are different methods are there, techniques are there to measure these distances, and to express the unit, they are definitely measured in meter, but to express those unit more easily, we have some alternative units, and that is what I am going to explain right now. So, here we have a image diagram in which you get to see the earth revolving around the sun. And what we get to see here is the distance between the earth when it comes here and the distance when the earth reaches here. They are not same, or in simple, the distance continuously changes. Distance continuously changes. So when it is very close here, when it is very nearer, the value comes out to be equal to nearly 1.47 into 10 to the power 11 meter. This is a very large distance, 10 to the power 11, when it comes very closer. When it reaches very far, the value comes out to be equal to about 1.52 into 10 to the power 11 meter. And now when we take the average of these values, average means mean value, okay, the value comes out to be nearly 1.497 into 10 to the power 11 meter, which I am going to consider to be equal to 1.5, if I use the rounding of rules, okay, then I will get 1.5 into 10 to the power 11 meter. And we call this value as astronomical unit, and we denote that as AU. So this is one of the special unit used to measure large distance. What is one of the unit? There are many other. This is one of the units. So what is the first unit? The first unit is called astronomical unit. So what do you mean by astronomical unit? Astronomical unit is nothing but the average distance between the sun and the earth is called astronomical unit. Average distance, mean distance is called astronomical unit. So that is one of the unit which is used. So what are the other units which are used? So the first one is astronomical unit, which is equal to 1.5 in 10 to the power 11 meter. The second unit is called light year. We denote by LY. And 1 light year is equal to 9.5 into 10 to the power 15 meter. What is this 1 light year means? 1 light year means distance traveled by the light in 1 year. So what is 1 light year? Distance traveled by the light in 1 year is called 1 light year, and that 1 light year is equal to 9.5 in 10 to the power 15 meter. See, which is the nearest star to the earth? That is sun. And from the sun, once the light is emitted, it takes nearly 8.3 minutes to reach the earth. So we don't get light immediately. It takes 8.3 minutes. From there till here, it requires 8.3 minutes. Now, which is the next star which is the nearest to the earth? It's called Alpha Centauri. And that Alpha Centauri is nearly 4.4 light year away. What do you mean by that? It's very easy to understand. Once the light is emitted from that star Alpha Centauri, it takes 4.4 years to reach the earth. Isn't it interesting? I hope you understood the meaning of it. For example, if I say there are stars, which are still at a large distance, several stars, some are 100 light years away, some are 9 light years away, some are several billion light years away. What do you mean by 100 light years? Suppose if there is a star which is 100 light years, that means once the light is emitted from that particular star, it takes 100 years to reach the earth. So our lifetime is not enough, to get that light once it is emitted. So that is the meaning of the word light year. 1 light year means that light emitted from a star takes 1 year to reach the earth. Imagine if it is 1 light year and if it starts emitting the light at this moment, then it takes 1 year, 1 more year to reach the earth. So, that is the distance how it will be measured. So, therefore, number of stars are there which are very far away and they are several light years away, and that is why we make use of, instead of saying the star is at a distance of 9.5 in 10 to the power 15 meter, I can very easily express, we can say that that particular star is 1 light year away. 2 light year means I have to multiply this by 2. 10 light years away means multiply this by 10. So, this is the conversion between the unit in light year and the meter. So, these are all unit of distances, different units of length, especially large distances. We do not measure length of this chalk in light year. So, only large distances are expressed like this. Okay. So, which is the first unit? Astronomical unit. Which is the second unit? Light year is the second unit. And do remember all this conversion, because they will ask this kind of conversion for 1 mark in the examination. Okay. The third one is called parsec. Parsec. It is basically the meaning of the parsec means parallactic second, that is in short form we write it as parsec. And 1 parsec, which we write it as a PC in short form, that is equal to 3.1 into 10 to the power 16 meter. So, 1 parsec is 3.1 into 10 to the power 16 meter. Now, what is the meaning of 1 parallactic second? Suppose if I consider the sun, this is the position of the sun, and if this is the earth, position of the earth, and if this is the average distance, then that will be equal to astronomical unit, because we know that average distance between the sun and the earth is called as astronomical unit. Now, imagine here if there is a star, which is at a very large distance, star. With this line, it makes a certain angle here, correct? See, with this astronomical unit, it forms an angle. And if this angle is 1 second, now you may wonder what is this second is. See, 1 degree we can split into 60 parts and we call it as 60 minute. And 1 minute, that angle, I am talking about the angle, that angle can be further splitted into 60 more parts, and that is called 1 minute is equal to 60 second. So, these are all units of the angle, smaller. 1 degree splitted into 60 parts, what do we call? 60 minute. And that 1 minute, if I further split into 60 more parts, then that is called 60 second. So, therefore, if this angle is that 1 second, then this distance is called 1 parsec. So, 1 parsec is nothing but the distance at which 1 astronomical unit forms an angle of 1 second. And what is the value of that parsec equal to? Parsec equal to 3.1 into 10 to the power 16 meters. So, this is the third unit of the distances, which is parsec. So, do remember the first one, 1 astronomical unit is equal to 1.5 into 10 to the power 11 meter. 1 light year is equal to 9.5 into 10 to the power 15 meter, and 1 parsec means a parallactic second, PC in short form, is equal to 3.1 into 10 to the power 16 meter. Okay. See, they have asked 1 more question this year in the district level exam. What is the question? How many meter makes 1 parsec? So, what is the answer? The answer is here. You have to write 3.1 into 10 to the power 16 meter makes 1 parsec. Okay, it is a 1 mark question. What are the other methods by which we can find the large distances? And the method is called parallax method. So, that is what I am going to explain here. You get to see the surface of the earth. See, this is the earth here. Okay. And you get to see some stars as well. Hope the diagram is clear. So, I want to find the distance of one of the star which I have marked. Now from two different positions, from two different locations, which are at a distance b. So b is called the base. So b is the base. Using telescope, the stars are viewed simultaneously. Okay. So this is how the star appears. So the star appears here. Again from the other location, because one star is visible from lot of location, right, on the surface of the earth, correct? So again from another location, the same star is viewed like this. And now here we can measure this angle. This angle. I am going to mark that as a theta 1. Correct? No, angle made with the vertical here, that is theta 1. Again here we can measure this angle, that is theta 2. And now if I use the diagram like this, how much is this angle and how much is this angle? This line and this line are parallel. So therefore, if this is theta 1, even this also becomes a theta 1, right? Alternative angle, correct? So if this is a theta 2, this also equal to theta 2. So what is the total angle? Total angle is the theta is equal to theta 1 plus theta 2, and this total angle here is called as parallax angle. It's called parallax angle, or it's also called as a parallactic angle, theta, which we can measure it very easily. We can even measure the value for B, two location, how far the two locations are. So we know the value of B, we can find a theta. So B is called the base. And now since this star is a very large distance, all these three lines are almost the same. This value, this value, this value. This is a D, this is D, this is D. Where capital D is a distance of the star from the earth. From the earth. But do remember that this angle is very small. The angle made there is very small angle. So therefore, if I use the formula of the arc, we have learned basics, correct? Arc length, arc. This is arc. This is a theta. This is the radius of the arc. This is the arc length. What is the relation between the arc length, the radius and the angle? The relation is S is equal to R into theta. S is equal to R into theta. Therefore, here when theta is very small, this arc becomes almost a straight line. That is only when theta is very small. And we have a similar situation here. Check this diagram. So this is a B, base. This is the parallax angle, and this is that distance. So how do we relate? Here S is equal to R theta. Here what I have to write? B is equal to D into theta. D theta. But our aim is to find a D, and that D is equal to B by theta. S is equal to R theta. Arc length is base here, which is equal to D into theta. So we have to find the value of D. So D is equal to B by theta. By knowing B, which is the base, and by knowing the parallax angle, we can find the distances of the various stars from the surface of the earth. So this is one of the important method by which one can find the large distances. It's important even for the exam as well. So hope you have understood the method of finding the large distances using a method called parallax method. So, question from the exam, explain parallax method of determining the large distance. So, just now I had explained it. So, that is you need to write in the exam. So, that will be either a 5 marks question or it will be a 3 marks question, but it is a descriptive where draw the diagram very neatly, explain finding theta 1, finding theta 2 and then write the formula that gives the large distance, which is a d is equal to b by theta. So, important question. Different units of mass. So, we are done with the length now. So, what are the different units of mass? I have already explained about it. The first unit is or the smallest unit which we use is called atomic mass unit, which is equal to 1.66 into 10 to the power minus 27 kg. How do we define atomic mass unit? So, 1 atomic mass unit is equal to, it is defined as 1/12 of mass of 1 atom of carbon 12 isotope. This is how we define. How to define 1 atomic mass unit? 1 atomic mass unit is defined as 1/12 of mass of 1 atom of carbon 12 isotope, and this is the smallest unit of mass used, okay, smallest unit, which is the largest unit of mass used. The largest unit of mass used is called Chandrasekhar limit, in short form we write CSL, which is 1.4 times the mass of the sun. Now, 1 Chandrasekhar limit, 1 CSL is equal to 1.4 times mass of the sun is a 2 into 10 to the power 30 kg nearly. So, when you multiply you will get 2.8 into 10 to the power 30 kg. So, the smallest unit of the mass is atomic mass unit, which is the largest unit of mass used, CSL, which is Chandrasekhar limit. And a question from the exam, define atomic mass unit which has appeared in the year 2016, and just now I have told you the definition. So, how do we define 1 atomic mass unit? 1 atomic mass unit is defined as 1/12 of mass of 1 atom of carbon 12 isotope. It is a 1 mark question. Next, mention the method of determining the mass of the planets and the stars. We know how to measure their distances, that is the parallax method which is used. How do we measure their masses? We know at present the approximate mass of the Venus, the mass of the Mars, the mass of the Saturn. So, for that they use the gravitational method. Okay, what method? The gravitational method is used, where they measure the gravitational force between that planet and the satellite which are moving around it, and thereby we calculate the time period of revolution of the satellites using t is equal to 2 pi root of r cube by gm, and by knowing time period of revolution of the satellites around a planet, the mass of that planet can be measured. So, this technique, this method is called gravitational method. So, what is the answer to this particular question? Mention the method of determining the mass of the planets and the stars. It is by gravitational method. The range of measurement. What do you mean by the range of measurement? Say in the case of the physical quantity length, what is the smallest measurement that we have measured so far, that we have successfully we have measured it? The least value is 10 to the power minus 15 meter, that is the smallest measurement made by human being, smallest measurement so far, that we have discovered, smallest. What is the largest value that we have measured so far, which is 10 to the power 26 meter. Now, what these values refers to? 10 to the power minus 15 meter refers to the radius of the nucleus of the hydrogen atom. Radius of nucleus of hydrogen atom is of the order of 10 to the power minus 15 meter. Then, what is this 10 to the power 26 meter? The 10 to the power 26 meter refers to distance to the boundary of the observable universe from the earth. Now, what do you mean by observable universe? Observable universe means from the earth, this is the earth. So, we are able to discover a certain distance, and this value is 10 power 26 meter. That means till here we have succeeded in finding what is the content, what is the constituent of this particular entire universe. That doesn't mean that there is nothing beyond that. No, we are yet to find the matter which is present beyond that. So, that is the meaning of observable universe. Observable universe means the universe which we have discovered so far is called as observable universe, and that value corresponding to that distance is 10 power 26 meters. So, what is the smallest measurement that we have discovered? 10 power minus 15 meter, and the largest is 10 power 26 meter. Now, this is regarding the length. How about the mass? The smallest mass that we have discovered is 10 power minus 30 kg, and the largest mass is 10 power 55 kg. Now, this 10 power minus 30 kg corresponds to the mass of the electron. That is the smallest mass that we have measured, discovered. And 10 power 55 again refers to the mass of the observable universe. So, mass of the electron and the mass of the observable universe, everything including the planets, everything, if you include all that matter which is under the observable universe, then that mass comes out to be nearly of the order of 10 power 55 kg. So, this is the range of the mass discovered so far. Similarly, what is the range of the time that we have measured? The smallest time that we have recorded is 10 power minus 24 second. It is such a small value, student, such a small value, 10 power minus 24 second. But still the scientists have achieved in measuring such a small value. And the largest is 10 power 17 second. So, this is again a very large value, 10 power 17 second. Now, what is this 10 power minus 24 second refers to? Now, that refers to lifespan of most unstable particle. What do you mean by unstable particle? See, we have particles like electron, proton and neutron. These are all stable particle. For example, proton and neutron is stable inside the nucleus. Electron is also stable. But there are certain particles which are unstable. That means they will not remain as the same particle. They change into some other particle. For example, neutron is stable only inside the nucleus, and outside the nucleus it will remain as a particle only for about 16 minutes. You may ask, what happens after 16 minutes? That neutron splits into two more particles called proton and electron. So, neutron will not remain. Now, this is called unstable particle or instability. The particle will not remain as the same, it changes into some other particle. And there are particles whose lifespan is only 10 power minus 24 second. Within that 10 power minus 24 second, they change into some other particle, and we have achieved in measuring such a small time limit, which is 10 power minus 24 second. So, there are atomic clocks are there. With the help of these atomic clocks, we can measure these kind of measurement, 10 power minus 24 second. And 10 power 17 second is nothing but again the age of the universe. So, age of the universe is found to be about 10 power 17 second from the theory of the Big Bang. Then what is the time elapse? That is found to be about 10 power 17 second. So, these are the range of the measurement made by scientists for length, and then for mass, and then for time. And they may ask in the exam the ranges of the mass, range of the length, range of the time. So, that is why you have to remember all these ranges. So, hope you have understood the topic that I have explained regarding the measurement. So, we have a few more topics left. After that, I am going to conduct a test. So, that is why start preparing, students. My best wishes. Thank you.